Okay, folks, welcome back to the Python Made Easy series. We are going to talk about the topic of decorators today, and we'll focus on function decorators. This can be a topic that is extremely confusing, but we're going to try to make it easy. We'll define what decorators are, we'll see where they're used, and then we'll see how to use them, chock full of examples, and one that's extremely practical, and I hope it's helpful to you. What is a Python decorator? A Python decorator is a function returning another function, usually applied using the wrapper syntax. It's a tool for adding logic that manages both functions and classes. You can apply them to both. It's a way to run extra processing steps when functions and classes are defined. There are two different types, the function decorator and the class decorator. The function decorator specifies special operations for both functions and classes methods by wrapping them in an added layer of logic that presents another function. This added functionality is usually called a meta function. This is a function that manages another function. They are specific to a given function or method. Class decorators augment class definitions. It adds support for objects and their interfaces. So let's take a deeper look into what decorators are before we start to leap into the code. A function decorator is a runtime declaration about the function that immediately follows. The syntax looks like this. We have the sign followed by a word that represents a meta function, a function that manages or acts on another function. And that's immediately followed by the actual function that we want to decorate. The syntax above connects the method tally_deco_inst to the decorator's results. So when the method is called sometime later in the code, this brings forth the results of the decorator first. So for every call made to this method, the decorator is run and processed. To make sure we don't get very frustrated when we start to look at the syntax and the code that represents decorator functions, let's first review a few core concepts and definitions. First class functions. All functions in Python are first-class functions. This means that we can treat them like any other object in Python, like a string or an integer or what have you. So they are able to be passed as an argument, returned from a function, assigned to a variable, and can be stored in data structures like a string. Executing a function takes this form, the function name and the open and close parens. That will return the function and execute it. Making an object or a variable equal to a function will take this form. X equals myfunc. No, there are no parentheses. This will not execute the code. This only returns it. X now can be used in place of the function myfunc. Higher order functions are functions that can accept other functions as arguments and return functions to the caller. So let's look at this code. We have a function def hi accepts a message parameter and then prints out that parameter. So we have f equals hi hello. So this calls to our function, returns it, and executes it because we have the name of the function and the open and close parens, and we pass it obviously the attribute that it's looking for. So you see on the right hand side, the code output confirms hello is returned because we have the print statement in the body of the function. So f equals hi. Now f is our function hi. When we print f, this verifies that f is now our function hi. We get confirmation through the output. So now we can use f in place of hi. So I say f, I'm a function now. So again, we have the parentheses here. So we are able to now not just return the function, but execute it. And you see in the output, that's confirmed. I'm a function now. So this is all about, am I returning the function with or without the parentheses to make the distinction between returning and being ready to be executed or returning and executing. And it's also about turning a variable into a function. Okay, so hopefully that's clear. And I think if it's not, as we go through some of the code examples, it's going to start to come into focus. But when I learned this, and I continue to have to review it and reinforce these concepts because it can get a little confusing. So don't give up, just keep reviewing. Okay, so let's try to make higher order functions completely unambiguous by way of a snippet of code. A reminder, a function that can accept other functions as arguments and return functions to the caller is defined as a higher order function. So here's our code. We have def adder with the parameter of num, and then we return num plus 2. We have a second function, myfunc, which takes a function as an argument, and that returns func plus is your result. So we create a variable addMe, which equals adder function, our first function, and we pass it the integer 4. So if we print addMe right now, it's equal or takes the place of adder 4. So it's going to print out the result of just running that function, which is 6, right? 4 plus 2 is 6. Now, if we print myfunc, which is our second function, and pass it addMe, which is our function adder, addMe is the argument for the function parameter in myfunc. You see that? So we are passing myfunc a function. And when we do, we return func. The return of func is what? Is 6. We just went through that, right? 4 plus 2 is 6. So it returns the output, what the function returns, plus is your result. So 6 is your result. So that's it. That's as simple as it gets for higher order functions. Okay, so now we'll jump into closures. And this is going to propel us even closer to our end goal, which is to really understand inside and out what decorators are. So returning a function from within another function is a closure. A closure is a function object that remembers values in enclosing scopes, even if they are no longer present in memory. To be a closure, these 3 conditions must be met. Number 1, there must be a nested function in place, so a function with inside another function. 2, the nested function must make use of a value defined in the enclosing function. And 3, the enclosing function must return the nested function. Okay, so let's go through this code in detail. GetName is a function returned by the names function. However, this does not execute the function. Note, it is getName which returns the function as opposed to getName with the parentheses which would execute it. That's the distinction there, very important. The string Mickey is the argument passed for parameter fname. This gets attached to the code within the getName function and is remembered even after it is no longer present in memory. N is now the same as names. The getName function now takes the names function as an argument, passing in the string mouse for the lname parameter. N is a function object and now represents the getName function's return statement, as that's what's returned by the names function. We can confirm this by issuing the command print and then feeding that the argument of n._name__, and the output you will get is get_name. So if you're ever confused, don't be afraid to make use of that name method and print that out and see what you're working with. This meets all the tenets of a closure, and you can see that it prints out, as we would expect, Mickey Mouse from the return of our fname concatenated with lname within our getName function, get_name function. And if my code snippets start to look a little different, I decided to test drive Microsoft's Visual Studio as an IDE for this section. So we'll see how it works. I'll let you know as we go along. So here is our first decorator. Ta-da! All right, let's go through it. First of all, we have a function called decorate. I guess I mean this is the one that'll be decorated. And up here we have our decorator function. Here we have our wrapper function, which is nested inside the decorator function and returns func1, which is passed as the function that will be decorated. And here inside the decorator scope, this returns the output of the wrapper function, but doesn't execute it, right? There are no parentheses, so we learned that in the previous slides. And here D is equal to our decorator function and passes it our decorate function as its sole argument. Our variable output equals the wrapper function, the return and execution of this, and that is because that's what is returned in the decorator function itself. You can confirm this by printing d._name_. This prints the output, which is the execution of the wrapper function. And now you see down here is the output produced from this code. I'd like you to notice the order in which things get printed out. So the first thing that gets printed out is what is in the decorator function, right? This is from the decorator function. then what is printed from the wrapper function, and finally the last thing to happen, as you would expect if we want something to be decorated on, the decoratee gets printed out last. So all that other stuff has to happen first. It's like a gatekeeper, right? We pass through all this stuff, especially when I show you an example later, if we want to make sure, say, somebody's logged in as a certain user or from a certain group before you execute what's in the actual decoratee function, the thing being acted upon. So now in this slide, we take exactly what we did in the previous slide and we rework it to take a slightly different form. We are going to use what would probably be most recognizable to most, the @ symbol, to create the decorator. We can fly in what we had in the previous slide to compare and contrast. So all of these top lines here, up until we use the @ symbol for our decorator, are identical. They're exactly the same, no changes. And the decoratee, the thing being decorated upon, that function, stays exactly unchanged. So what is the change? Well, we have that @ decorator, and then all this other stuff down here, D equals decorator, passing it decoratee, and the output equals D, and then printing the output, all that stuff goes away. And in its stead, the only two changes are, again, that @ decorator, right? Because that is going to be the name of the thing that's doing the decorating. And then we print decoratee. And this actually intuitively makes a lot more sense. Whenever we want to decorate something, we want to call the thing being decorated, and then we want there to be a layer of abstraction. Okay, this other stuff is happening in the background. So this way, every time we call it, it will be decorated. So all we have to do is worry about calling the thing that we want to call, that thing that will be decorated. So the output is exactly the same, in the same order, and nothing else changes. And here is an even more practical example that you're likely to run into. I first ran into decorators when I was working with the Django framework, and I decorated a view that allowed somebody access to a specific section of my website. And the decorator said, yeah, but you have to have these credentials to pass go. In other words, I'm going to keep you from entering unless you can satisfy me that you have the right credentials. So this kind of does the same thing. I mock this up. So what's happening here? First, I import the getPass.getUser function to get the username. So this allows us to understand what user we're dealing with. That's the reason why I use this particular function. The function that I'm decorating is able to open a file, read it if the permissions are correct, and then print it out to the console. This here is the decorator that will evaluate the user credentials. Decorator _ UN. This is the decorator that takes one parameter. In this case, it is my print to file function, the decoratee. This returns, but doesn't execute the test run wrapped function right here. The test run function completes the test to determine if the user credentials are correct. The idea is if the credentials obtained by the getUser function pass the test, printfunc, and this is our print to file function, will be returned and the file's lines will be printed out. If not, the string wrong user will be returned. This executes the print to file function, upon which the decorator runs first to ensure the permissions are correct, and only after that is confirmed will this function be permitted to run. Our code is shown right here. First it says you have the correct permissions because it's looking for my first and last name, and then it prints out what's in the file. And finally, it prints out success, which is the return of our decoratee function. So take a look at this. This is something that, again, I think is more real world and hopefully resonates with you a little bit more as to why you'd want to use decorators in the first place. All right, Python family, thank you for watching till the end. If this class has helped you, consider helping me to continue to bring these classes to you and others. Helping is easy. Just do the following. First, subscribe to this Yogi Coder YouTube channel. Next, like this video and leave whatever comments and questions you feel moved to. And finally, share this video on any and all social media channels with your friends and colleagues. And always, the presentation and associated code will always be stored up at GitHub at the link that's provided in the section below. Thanks for tuning in, and I'll see you in the next one.